see a lot of things, a lot of fantastic things. I remember I was once in Geneva, and it was the very first time I saw firmware or other software from GE, Siemens, and I thought everything is done. We have nothing to do. But when I went a little deep in all these softwares or all this solution, I found out that there was a lot of things missing. So that one of the problems was that you have to communicate from the IoT to, for example, the other systems. For example, intelligent transport systems. And to make happen things like, good morning to the driver. May I show you today there's a cherry blossom along your street. It's not very easy to be done this, because there's a lot of different domains that have to talk together. And the same things, when you suddenly break your car, this packet should be broadcasted to which car? To all the car in the surrounding, or just to the car behind you? Because you don't have an infinite amount of bandwidth to deliver packets. The packets should be delivered efficiently, and especially if you put, for example, cryptography on it, especially you have IPv6, or you have a lot of payloads, and it's narrowing. So we came to the IoT, let's say like life sometimes something, just by chance. We're an infrastructure company, we are not a research company, we are not a university. I'm an electronic engineer, of course, but I'm not a researcher for the first instance. So, what do we do? We are well known in Italy for the Impossible Mission Company. And we came to this project, to the IoT project, to ideas, to smart cities projects, just because some of us know that we can do something impossible. And what was impossible? There was a tender in Italy, Smart Road, a big tender, that nobody was understanding what to do, so what you have to do. Because they imagine that, sometimes a fantastic word, where IoT, drones flying over the streets, can deliver messages automatically to an ITS. And all of things happens automatically. When we were involved in this project, I started asking the different vendors, the IoT vendors, the ITS vendors, but about the technical issues or technical specifications. And every of these vendors tell us the same things. You are the very first one who really noticed the problem. So we decided to go further and to go deeper in this. So we, using our approach, because we deliver successful project to customers usually, okay? So with this in our mind and maybe in our heart, we try and we start to analyze all the different components we have. And talking about the Internet of Things, we have a lot of components. When we just talk about network, there's so many protocols available to you when you have to connect sensors. Which one is the right one? Which type of protocol? Which type of gateway? To the cloud, in the nearby, to the fog, in the roof, because we have a new definition of that, let's say standards. So we, at the beginning, start to make some order. So I just, because we are nearby Hong Kong, I just put a photo of a cross, and you can imagine how it's difficult, or maybe impossible, to pass from something like that to this. The autonomous vehicle, people are talking, cars flowing, no driving, they're making some video conference. Maybe in this context you need a Wi-Fi on motion, but some project starts from the end. They put Wi-Fi in motion at the very first, and they forget the other thing, the other things. But more important than that, So, which is the smart city requirements? Maybe you remember one of this picture in one of my colleagues, my presenter that was produced by me. But this is a real one, a real project. So what we have, this is around 3 kilometers square of city for one of our customers, and you see here all the router access point, the wireless access point. We see the mesh access point, and different color because on some of this tower we have Wi-Fi and LoRa, for example, to acquire the sensors. We have at the center of each cell a meteorological cell. Why need meteorological? Because how we can forecast pollution if we don't know how much wind it is, from which direction it comes, and if it rains, and then how much it rains or how much it snows. Sometimes even some of the European directive forget this. We'll see later. So this is an ideal smart of things infrastructure. So the root access point, each kilometers is quite a block. Then we have a root access point just in the middle with a weather meteorological station. We have the mesh access point by 250 meters, just to avoid interference, to avoid building constructions, and so on. And of course, you can put on top of this camera, intelligent camera. That's very, for example, in Italy, they are very attracted the municipality by cameras because they can make fines with which they pay this project, the smart city. So, what is smart? I remember a question before about that. Smart for us is using the right network, the right information, and delivered to the right device and to the right user. We forget about smartphones, about devices. We let devices to app developer. So we just build the framework and present all this information to the upper layer. Has to app developers can use it as they want. And you see later.
How about understanding how people would like to live their lives?
But it's a good question. I think in the next question, in the next pictures we'll see. Okay, so we have different goals, of course. Stakeholder goals. So enhance road safety, traffic flow, reduce the incident because it costs less to collectivity, enhance user experience and user interaction, a user interface. Of course, we have environment protection and monitoring. And of course, for example, congestion avoidance. So we have a lot of objectives, maybe different and done by different piece of network, but should be done. For doing that, we have a lot of infrastructure. I just put 3 of this, the one we use, for example. So we have the IoT sensors, a low power WAN, because, okay, in the next presentation, we get to talk about blockchain. I heard yesterday about blockchain, because it's quite, it's very common to speak about blockchain. But blockchain needs a lot of power, computational power. And on sensors, we have opposite, we have to reduce consumption. We have to use less power as we need. So, and then we have this protocol for use for example, for intelligent transport systems, because sensors must feed the IDS. Because if you want to show how much rain is on the street, you have to collect from somewhere else, not just from the IDS. Sometimes when you go around some conference, you can see a lot of vendors showing you their IDS systems. They are movies. Okay, and then because we have to secure this platform, we have to put a sort of gateways. Once we talk, someone is whole like me. Remember the IP to IP gateway. First we use the voice over IP systems. Okay. Okay? So something like that, is a sort of gate to protect sensors and devices from others. Imagine a motorway concession, a municipality that builds network. Why another developer, for example, running an app on parcel delivery, pizza delivery, parcel, everything, should build another network? Why don't they use that network? And why we don't give the chance to this concession, to this municipality to monetize infrastructure? You want to have access with this app to this infrastructure? Pay as a service. That's the concept of mobility as a service. So you build infrastructure and you give the app developer the chance to access this infrastructure based on a base service. So, of course, in Europe we are full of directives and standards, and we have to develop on this. Imagine that this group spent more than 1.5 years discussing who data belongs to. And they finally agreed that the best thing to do was to put a red button on the IDS on cars to switch off the IDS. Imagine what happens if I do that and then this car happened to be in an accident. It's like an airplane flying. It's because the commander don't want to be traced and switch off his tracking system. It's something quite strange. But they don't talk about, for example, rain intensity or snow intensity. They just put in this directive, in this specification, yes, directive, just if it rains or no rains. But you can understand that it's completely different to detect if it's raining or it's not raining, because you need this info, because how much is raining? Yeah. So that's a little layer we have done. So we have to build all these components. So here we have the things and the users, okay? Like that. If we go south to north, we have all the communication layers. Say, in the presentation of Roberto said we have to aggregate. So we have to build some common homogeneous things, okay? Of users, of devices. Up, we have the message broker. It's one of the most important things of the solution. So we have to dispatch messages to the right system. That's very important. Now if we move on east to west, we have, of course, identity and access management. Well, that's all you, the IP2EP gateway. So who can access to the sensor and which part of the sensor can access to? All to the IPS, of course. If it's raining, it's something public available? Yeah, of course. How much is raining? Yes, not secret. How much cars are passing by a certain traffic cross? Could be. So we have different layer of privacy. So we can't do, like some regulators do in Europe, not 0, 1. It has some different way of weighting the right privacy. Of course, we don't know, we don't have to know who is in the car. This may be interested by insurance company. If the person click on that button, he can accept, for example, that his data can be transferred to an insurance company to have a reduced fare. But if we just know, we just have to know where is the car to avoid accidents, to letting them to avoid road works, for example, or traffic jam. We don't have to know all this, Mr. Sean or Mr. Mazzola. Just know there's a car there. So, no privacy problem for me. So, And then we have, of course, the device manager. We have a lot of software to do that. So maybe, may I say that most of the software, much of the software do this. So they manage the IoT, they manage this firmware, they manage the IP of this firmware, they manage all the stuff regarding that. Who deals with the optimization of the packet delivery of these sensors? Not this. Going up to the north, so here we have one of the most important parts of the software of the solution is the event processing and analytics, because what happens when a car is entering a tunnel and on the outside it's raining, it's heavy raining. So the software has the capacity to analyze how much is raining and tell the ITS that there is a warning and to speed and to tell the driver to lower speed. And if in one day you have an autonomous car, automatically do that, because the onboard unit can talk to the CAD bus of the car, and the CAD bus can talk to the actuators of brakes and all the other stuff of the cars, and reduce speed. The same thing happens if we want to reduce, for example, pollution. It's one of the projects we are involved in the north of Italy, in the Passante di Mestre Verde. There is a piece of work in the north of Italy, in Venice. They want to make very green. So what happens if there is a lot of noise or a lot of pollutant? We send to the IDS the info of reduce speed to make less pollutant. And on top, we have the classical web portal, the dashboard, for example, for the traffic management systems of the municipality or the organizations, and then the API management. So the API, but we can deliver to the upper level, to app developers, whatever they want to speak or talk with the lower level. This one slide, obviously designed for this context that normally take off of my presentation, because normally customers are not very interested in that. But as we are in a IEEE conference, I thought it was the case to show some of the basic, there's a lot of recommendations, basic standards we use when we design our solution. And they are very interesting. Imagine that IEEE, for the software, we don't have standard, so we have recommendations. So it's quite a little different. That we name like the same. So one of the very first, or the very important, very first is this one, P24130. But it's just for the architectural standard. It's just a top-down approach, and it's the one we have used in our designing our systems. Then we have these interesting standards. If there are some students here, I suggest to look into all these standards. This one is very important. We started a little bit on it because one of the problems we have is latency. We saw a lot of things here, but I always place one question. What about latency? If we have a car traveling 120 kilometers per hour, it makes 33 meters per second. 5 seconds of blackout, it will be these cars with around 150 meters with no control. So latency is really very important. And imagine that actually, if we rise too much the cryptography, for example, from 128 bits to 256, the latency we registered was unacceptable to have something like that. So you have to take all these things. And imagine in a very crowded city or in a very crowded motorways, where a lot of cars are passing by. There's a lot of other problems that can be done. It's too much problem, but we solve part of them. So the last one just is to check about the quality of sensors, because when you put sensor for pollutant, they have, they don't have an infinite life, but they have to be rechecked every 3 to 6 months, so pay attention to that. Okay, some standards even for the IDS. Very well known is the 802.11p, but to have this protocol work with the environment, with cars and with traffic, you need to be some pieces on it. I don't go deeper. Well, the presentation will be on the IEEE side. So we need somewhere of pieces to have all these other things taken account. So, and as we put some pieces of software-defined radio on that, because just to not to go too much technical, but we have to put on each device a sort of a software switch and software router, because we should have the capacity to manage packets that comes from the outside, and we have to discard packet we don't need, accept that packet we are necessary. So we have to put some intelligence on all this stuff. Okay. So many colleagues around Europe make tenders for the IDS, mainly for just some of these studies. Imagine that the protocol 802.11p has a coverage, an extended coverage of 1 kilometer. So what they do, they just put the radio station every 1 kilometer. That's okay? No, it's not. It depends on how many vehicles you have. Because there's a lot of problem for interference. So as you can see, this is the complete study I just put here for reference, but you can see that if you have the maximum amount of the signal strength, you go to 1,000 meters, okay? So when you have not too much vehicles, it's okay. But what happens if just you have 60 vehicles per kilometer? So after 200 meters, no package is delivered efficiently. So you have to manage, for example, the power of the signal. So it's a lot of things to take into account. Okay, so just what you need is integrate all these different components and take into really abundance the middle reaction time. So reaction times is fundamental. You just have all the intelligence in the cloud. Maybe this cloud is 1,500 kilometers far from your city or your motorways. For some customers, we are planning of developing a local data center to deliver the roof capability to all these systems. Because maybe part of the things have to talk together. What to say, Roberto? We have to make a sort group of this way. So, to do all this, you have to make the transmission control center aware of all this delivery, and then you have to let that information coming from IoT sensors can flow to the other part of the system. For example, intelligent transport systems, especially if you have one autonomous lane designed for express service, demo purpose, or whatever. You need model. Nobody tells you about that, but you need model, meteorological model, because you have to analyze what is going on outside. Because meteorological model has strong effect on pollutant, because the diffusion equation are influenced by moisture, wind, temperature, and all of this. So, what you need to give a user this, we don't do that, so we do all the rest. But to do that, to do this, you need all of this. So you need first a low power infrastructure. You need sensors, you need an environment model, software and software network, framework, info brokers, message brokers, but it's the dispatcher of all these things. It's the most important part of the systems. You need, of course, some analytics and big data. Of course, if you have 10,000 sensors delivering 10 measure or 1 measure per second, you know, and you need to create a model that is at least 1 year, multiply this amount of data, especially if we have to do for nations and not for just one city. The sensors, you know, getting even more. So, and then this is service that is very effective, and we are developing some piece of this with the university, just to have a friendly interface. You know, for example, for emergency car, you just put an OLED in the grand screen, and you can see the sensors while you are running in the motorway or in the cities, just to make easy the sensors. The colleague of Autodesk could be helpful in doing that, you know. And then on top, we have the microservices. So all these services that could be accessed from a cloud infrastructure, and then you can use on a base service model. You know? So very fast. This is the network infrastructure. Of course, I don't want to go deeper into this or to be technical. IPv6, for example, is used not only just because we have a large amount of address tree, but because of some smart, if I may use this term, to distribute package and routes locally. So it would be very useful if we take concern of some security problems. You know? So if you don't use the network device protocol, but the security device protocol. So different of structure of networks. We use LoRa and LoRaWAN, and as we have to go fast. As you can see, this is the typical sensor we use with a main board with 6 sockets, and we can plug all of this. We have a huge amount of force of network available. So if a customer has already Wi-Fi on it, we use this one, unless we can use Sigfox, but normally there is no network, we use LoRaWAN. So that's what I showed you before. So we can do that. We data sensors are flowed in the algorithm. We can add a meteorological model that splits flows into predictive algorithm. You can see on the website all of this, so it's real and it's available. And you can have a pollution trend, but could be deterministic. It depends on the budget of the customer. So what would be based on the forecast? That's the two. Okay. So all of this just to arrive to this. That shows the amount of rains, the pollutant, which is the safest way to go to one place, which is the healthiest way to go to one place. Okay. I don't know who remembers the ISO, almost eye level, same level, very old. So we've done something like that. So we have here the network, the infrastructure, we have the cloud, we have the big data ingestion and analytics, and all of this we have the application. So sensors, connection sensors. We have this piece of software that is here, the middleware, that is dispatcher of all these things. And all the upper layer I already told you about. So, just my last 2 slides. So that's the high-level infrastructure. So on top we have the business layer, and I show you, and all of these pieces of software that manage all the different problems we have in an IoT, Smart Indian Nations problem. So my last slide. So nations stop domain, you know, and then a lot of burdens. The red arrow are the one we are dealing with. So, but you know, you need all of this because Why smart agriculture? You say I talked to you about the cherry blossom, but if you are planning, you know, people in the world are getting much more. So what happens if we have to plan for agriculture, crops, for livestock farming? So imagine a system that can handle all this information and so can produce the right quantity of crops, right quality of livestock, animals like cows, dairies, and all of the stuff. It can feed all to these systems, as more cities can be fitted with all this information. Of course, we have met smart pedestrians problem because in the future, just people wearing smartphones, a lot of detection, a lot of sensors. Imagine something for blind people. No, I once met an app developer of this type of solution, and he was building an infrastructure dedicated to that. He said, you don't need that. The infrastructure is great. Just build the app and do the rest. Okay? And of course, sensor actuators speak. Why? Because when you need to reduce speed and you have an autonomous vehicle, you have to feed all this information to the brake, so to the actuators. Okay, we have done one of this project. This is me, and this is my colleague. This is the traffic management center in Venice, this little highway, and a successful project delivered. Thank you.
Do we have any questions from the audience? Thank you so much, and let's have another